Hi, so last week I shared the notes on visualization. I don't know if we received the notes. Is there anyone who didn't receive the notes? Okay, because we had asked for it and I made sure I'd forwarded the notes to all the contacts that we have. But in case you didn't receive, you can just get in touch and I'll send you. I think it's time that Dan can take over and start the class now that it's already 11:30. Dan, you can go ahead.
Okay, hi everyone. In the last class that we had on Friday, we were talking about visual encoding, and we looked at the various variables that you can use to encode data. So we'll just have a quick recap of those variables that we talked about, and then we'll proceed. So I've shared the screen. I hope you're able to see.
Yes, we can see it now.
All right, thank you. So so we're going to just have a quick recap of what we talked about, and then we'll continue. So we saw that encoding is translating data into a visual element like a chart or a map or whatever you're going to make. We saw that there are various ways of encoding visuals. We looked at position, length, angle, direction, shapes, area, volume, and color. Color being it's either saturation or a hue. So we looked at our position. That was where in space the data was. We looked at the scatter plots, upward trend, downward clustering, and outlier. By now you have these notes. I think no, not yet. You don't have these ones, but I'll share at the end of the lesson. We looked at length, angle, direction, shapes, area and volume, color, that was hue and saturation, and we looked at color blindness deficiencies. And then I gave a link to an illustration on chat suggestions, and I'll give you another link to another version of the same. This could just help you when you're making the decisions when you're choosing like the chat types that you're going to use. So today we'll begin on looking at the different data types that are there that you can visualize. So there are three basic types of data. That is something you can count, something you can order, and something you can just differentiate. So as often is the case, these types get down into three unintuitive terms. So we have qualitative, we have ordered, and categorical. We look at quantitative. Quantitative is anything that has exact numbers. For example, effort in points, we have 0, 1, 2, 3, 5, 8, 13, etc. Duration in days, for example, 1, 4, 6, 6, 6. So that is quantitative. We have ordered or qualitative. This is anything that can be compared and ordered. User story priority, for example, must have, it is great, it is good, not sure. Bug severity, it can be blocking, average, or who cares. Categorical is everything else. For example, entity types, we have bugs, stories, features, test cases. Fruits, we have apples, orange, and plums. And then, so we have planar and retinal variables. So we've got some data. Now we ask ourselves, how do you present it? We have several visual encoding variables. So we have in planar variables, we have X and Y. I think most of us have done, for example, visualizations in, even if it's on Microsoft Excel, we've come across the X and Y variables. So those are planar variables. Planar variables are known to everybody. If you've studied maths, you've been drawing graphs across the X and Y axis. Planar variables work for any data type. They work great to present any quantitative data. We have to deal with our flat screens and just two planar variables, which is limiting. We can try to use the z-axis, but 3D charts look horrible on screen. So we can see that when you're using flat screens, you're only limited to the X and Y. So we try to introduce what you call the z-axis. But the reason last time I'd say that 3D charts don't look very good in Excel is that it tends to focus the user tends to focus more on the 3D aspect, which is not really what you are trying to see when, for example, you are drawing 3D pie charts in Excel. So this is an example of an illustration with the X and the Y axis. So what would we do then to present three or more variables? For example, we can use what you call the retinal variables. Size. We know that size does matter. You can see the difference right away. Small is innocuous, that is insignificant. Large is dangerous, perhaps. Size is a good visualizer for quantitative data. We have texture. Texture is less common. You can't touch it on screen, and it's basically usually less catchy than color. So in theory, texture can be used for soft encoding, but in practice, it's better to just pass it on. So that's texture. We have shape. So round circles, edge stars, solid rectangles. We can easily distinguish dozens of shapes. They do work well sometimes for the visual encoding of categories. That's an illustration of shapes, circles, squares, rectangles, etc. Orientation is tricky. We have orientation. Orientation is tricky. While you are able to clearly identify vertical versus horizontal lines, it is harder to use it properly for visual encoding. That's orientation. We have color value. Any color value can be moved over a scale. Grayscale is a good example. While we can't be certain that that's a hexadecimal value of a color, that's hash 999. Color is lighter than hash 888. It's still a helpful technique to visualize the ordered data, as you can see in that illustration. That's color value. We have the hue. For example, red color is alarming, green color is calm, blue color is peaceful. Colors are great to separate categories. So the color hue is what we usually refer to as a color. When you say color, you're actually referring to color hue. So how to apply the retinal values to data? It is quite clear that we can't use all variables to present any data types. For example, it is wrong to use color to represent numbers 1 to 3, and it is bad to use size to represent currencies. For example, the euro, the dollar. Why would small circles stand for euro and large circles for pounds? It actually makes no sense because it is not, it doesn't represent size in any way. So below we have the retinal variables usage. We have a summary of the usage of the retinal variables. Let me share this link. I'll share this link on chat so that you can view a bigger version of the image. So a minute, I'm just trying to share. I'm trying to see how I can share these. Uh, Sorry, it's not that one. That one we'll get to it later on. Let me just. So there, the last link, the very last one. So we have that diagram. It's a summary of the regional variables that you can use. So we have categorical, ordered, and quantity. So for example, orientation here is categorical, it's ordered, and it's quantitative. We have the shapes is categorical. We have the colors, it's categorical. We have size, also categorical. The saturation is categorical, and then texture is categorical. So when you see where the green is marked, it means that for example, the first one is categorical, ordered, and quantitative, and so on. So that's a summary. So note that planar variables can be applied to all the data types. Indeed, we can use the x-axis for categories, ordered variables, or numbers. So I'll try to share the links as we go, then you can open them by yourselves. So let's look at a basic example. Let's tap on some techniques to visualize real data. Sample data is very simple. We just want to visualize quantity of items. So if you look at the screen, we have item type and quantity. Features, for example, is 3, bags 5, user stories, we have 6. We just have two variables. So we have item types, which is categorical, and items quantity, which is quantitative. All the possible choices are based on the table above. So we look at the possible choices on the screen on that table. So we have item types is orientation, color, shape, texture, X or Y, that's planar. And then we have item quantity, which is orientation, size, value, and X or Y, which is planar. So this is from this table here. An example from this table, we have item type and quantity. So in theory, you can mix these variables as you may wish, but we are now just trying to focus on 4 combinations. So let's look at, for example, shape and shape. We want to have shape plus value. So if you look at the screen, we have 3, 5, and 10. We have the square as feature. We have bag as a triangle, and then we have the user story as a circle. So in theory, you can mix these variables. No, sorry. It looks like a puzzle. I'm sure you don't understand what you're looking at. This doesn't really make sense. We're trying to visualize by shape and value, for example. So it looks like a puzzle. Value doesn't work for quantitative data. Let's try something else. So we try to look at color and size. So on screen, we have a feature, bug, and a user story. So as you can see on the screen, we have 3, 5, and 10. So we're trying to use size and color to visualize. Slightly better, color coding works for entity types. So for example, in a Target Process is a company that deals with the visualization. So we are using just one of the examples. So we've got green features, red bugs, and blue as user stories. So this still doesn't look very good. So let's try to use texture and Y. Remember we have X and Y. So we try to use texture and Y. So on screen we have feature, bug, and user story. Bug has texture, user story has texture, feature has texture. All of them have textures. So it's almost great. But why this legend with texture? If you look at the legend, it has a texture. We can just remove it. So yes, let's use the X and Y planner variables. So we're trying to construct the best way to visualize that sample data. So we come up with X and Y. So here we have a feature, bug, and user story. We have a bar graph without texture. So there's 3, 5, and 10. So now we have the best result. It turned out that X and Y works great for a simple data set with just 2 variables. So there's no need to use retinal variables at all. Retinal variables should be used if you need to present 3 or more data sources. So let's look at the 4 variables example. So 3 is trivial, we'll check 4. Say for example, we have bugs, stories, and tasks, and we want to visualize some properties of these entities. So we have types, priority, average effort in points, average cycle time in days. Below is our data. So if you can just take a few seconds to look at this table here. Type, we have features. So we have must have, we have good, nice to have, bugs, fix as soon as possible. We have fix if time, user stories, must have, good, nice to have. Average effort, we have 30, 20, 15, 2, 5, 8, 5, 8. Average cycle time, we have 40, 40, 20, 2, 8, 12, 7, 7. This is an example of a data set that we usually come across that we want to visualize. Probably it comes in an Excel format most of the time. So we need to pick 4 variables. So we pick entity type, priority, average effort, average cycle. So that type of data, for example, entity type is categorical, priority is ordered, effort is quantitative, cycle time is quantitative. Encoding variable, we use color U for entity type, priority U, average effort, we use X, and cycle time, we use Y. Now it's easy to draw the chart. The important bugs are shown in deep red, the unimportant ones in light red. The same pattern applies to features and user stories. So we continue. So here is an example of a visualization that we come up with using those variables. So if you look at the screen, we have bugs represented by that's pink, stories in blue, and features. And then we have the X and Y planner variables. So it's a mix. So what can we say about this chart? This one here. I hope we've all had a brief look at it. So what can we say about this chart? Here are some very useful observations. Bugs are usually smaller than user stories. I'll get back again to the chart. Bugs are usually smaller than user stories, and features are the largest entities. So that's by looking at that chart. Important bugs are small and get fixed quickly. Important features are the largest, and it takes more time to release them. Interesting information, by the way. Yeah. Unimportant bugs are the largest, and it takes longer to fix them. There's a good correlation between effort and cycle time. It takes more time to deliver large quantities. Correlation, you might come across correlation in one of the data science classes that you're having. So again, we go back to this chart. We say bugs are smaller than user stories, and features are the largest entities. So bugs is here is highlighted in the pink. So as you look at bugs, don't look at the size of the don't actually look at the size of the circle. Look at the x and y variables here. That is the cycle time and the effort, and look at the position of the bugs. So important bugs are small and get fixed quickly. I'll probably, when I give you these notes, you'll get to digest what I'm talking about when you actually look at this visualization in detail. Because I know it might not make sense to you right now, but when you have time, you'll just have a look at it in detail. So, of course, you can get the same info from the plain table above, but the chart is much more fun to explore. That's actually true. But the chart is much more fun to explore. So, like I said, when you look at the map at a glance, you'll have to really study to look at it, what it means. But looking at the table, again, like I said, in the human mind, it's hard to decipher numbers. Like when you tell somebody 1, 5, 10, doesn't make meaning unless you put it into the context of an image. And we all know that a picture speaks 1,000 words. So this is going to be the practical bit of this lesson. We'll have a small quiz at the end of the lesson to see whether you've gotten examples of visual encoding. So number one, so we look at this illustration, this visualization by New York Times. Let me share this link first. So if you can please open the very last link that I've just shared. I hope everyone has opened. We just want to discuss it briefly and see how the various visual encoding variables that we've talked about have been used in that visual. It's a visual by New York Times on Usain Bolt versus the world. So I'm trying to struggle with sharing two screens here, but I hope you are able to see the link on your laptops. So if we just look at that visual, so you can see that yeah, somebody says that you can all see. So if you can look at that visualization by the New York Times, we look at the various encoding variables that we've looked at. So we are going to we see that we have the use of color. Yes.
You stopped sharing again. We can't see it.
Oh, sorry. And now?
Yeah, you're good now.
Okay. So if we have a look at that very interesting visual, we see there's a combination of encoding variables that have been used. So for example, we have the use of color. Natural colors have been used to encode bronze, silver, and gold. So naturally, we know that the color of gold is okay. It's gold. It's a yellow. It's a variation of yellow. It's gold. Color of gold is gold. Silver is what? Silver is about maybe gray. So that's the use of natural color, which, if you can remember, we had said in colors, we try to use intuitive colors. So color has been used there as an encoding variable. So we have the use of color. So we have the X. X is meters behind Usain Bolt, which is quite unusual, but it's very impressive. So X, if you look at X, so here we have the meters behind Usain Bolt. You can even see the names of the athletes who Usain Bolt was competing with. And those bubbles that you see are interactive. If you hover your mouse over them, you get to see more detail. So we have the use of X variable. Remember we said that we have the X and Y as the planar variables. So X is meters behind Usain Bolt. And then we have Y. Y there is the year here on the side. So it's actually a combination of three encoding variables. So that is color, X, and Y. Or you can say color and then X plus Y. So that's an example of visual encoding through the use of color and then X and Y. So that is one. Secondly, we have Olympic medals. Again, this is by the New York Times. Let me try to share the link again. So for some reason, I have to stop sharing the screen before I share the link. So I'll have to keep going back and forth. So there. I hope you can all see I've shared my screen again and I've shared the link. So this is the Olympic medals. This is a visualization on Olympic medals. So if you look at that visual, so we have encoding variables. So for example, we have color for continent. Color represents continent. We have the size of the bubble represents the medals count. So this is the bubble chart that I was even talking about some time back. The size of the bubble represents the size of the of the data. So we have medals count as a size, and then we have the X and Y as the world map. So again, a combination of three encoding variables: color, size, and X and Y. We go to example number 3, baseball team's performance. I will share the link again. The last link there. So that one might take a while to open. I'm also opening on my end just to ensure that yeah, it's opened. So up there, you can click on the timeline. There's a timeline up there that you can see. You can use it to navigate back and forth through the previous years. And you can click on average, proportional, and win or loss on the side, on the legend. At a later lesson, you are going to see that showing or hiding values is one of the ways of creating an interactive visualization. So you can use legends to filter. You can click on win, loss, average, or proportional. So going back to our presentation. So I hope you can all see back to the presentation. We have this baseball team's performance visual that we've just opened. So we look at the visual encoding variables. We have the Y as the baseball teams there, Y-axis. Again, we have the on Y-axis the salaries. That is on the right. You can see that there's the salaries. We have color. Color is a trend. It's either good or bad. So the red represents bad, blue represents good. Those are intuitive colors that we were talking about. Then we have the size represents salary. The size of the strokes, the size of these ticks represents salary. So that is an example of encoding using the variables color, size, and then X and Y. So that's example number 3. Another example is a basketball team's performance. Perhaps it's a good idea if you leave the visualizations open so that you can refer to it later on after the lesson. So number 4, we have basketball team's performance. I'll share the link. So I've just shared the link there on chat. I'll give you some time to just hover over the mouse, over the visualization. So this is a basketball court, as you see. So when you scroll down and roll over the image, for example, of LeBron James, you can see how many points per attempt he had, and then the total points. This kind of visualization is actually custom made. You don't have a tool that gives you this kind of a visual. It's a combination of many types of charts. As you scroll down, you can also see there's the Dwayne Wade, Russell Westbrook. You hover, you get more info on them. So I'm just trying to go back to our presentation. I'm having a bit of challenges here technically, but so I hope you can see on screen. So we have our visualization. I hope you've clicked. So basketball team's performance. Let's look at the visual encoding variables that have been used. So we have X and Y is the basketball court map. This one here, you can see the arc. So we have again color as a point per region. The color there, you can hover, then you can see. Then we have size as the number of attempts. The red, the green, those visuals represent size as the number of attempts. So when you get time, just have a thorough look at that visual and you'll see that it's very It's very insightful. So that was example number 4. We go to the last example of visual encoding variables, which is football clubs league dominance. Again, I'll share. So the last link that I've shared is an example of this is a static infographic. We said that we have interactive and static visualizations. So if you've opened it, you can zoom. You can zoom in or zoom out. The legend, if you zoom out, you can see the legend on top is you'll see the blue triangle is a shot, and then the red circle is a goal. So if you look at that legend and then you can zoom in just to study to have a thorough look at the visualization. Sometimes these types of visualizations are usually not, you don't just glance through them to get insights. So if you've taken a look at it, we'll have a look at the visual encoding variables. So we have X as the timeline. From the visual, you'll see X as the timeline. We have Y as teams, and then shape and color, we have event. So that is goal, pass, and shot. This is an example where shape has been used as a visual encoding variable. So we've looked at examples of the visual encoding variables. As we continue with the lesson, maybe you can also continue digesting. Let's look at perception of visual cues. In 1985, William Cleveland and Robert McGill, then statistical scientists at AT&T Bell Lab, published a paper on graphical perception and methods. The focus of the study was to determine how accurately people read the visual cues above, that is excluding shapes, which resulted in a ranked list from the most accurate to the least accurate. So as we can see in the diagram below, so down here, as you go to the left, we have the more accurate visual cue, and then to the right, we have less accurate. So we had looked at position, length, angle, direction, area, volume, saturation, and hue. So through this diagram, you can decide on which type of visual cue that you want to use, depending on whether you want more accuracy, You choose one. So when I share the notes, you look at it and decide which one you want to use. A lot of visualization suggestions and current research stem from this list, which places bar charts above pie charts, heat maps at the bottom, and so on. This is sound advice, as you can see more on this chapter later, visualizing with clarity. But remember that this list doesn't mean that dot plots are always better than bubble plots or that pie charts are evil. Following this list blindly is an oversimplification of what the visualization is. Regardless of what you want to visualize data for, it's good to know how well people can read your visual cues and what information they can extract. So in other words, use these rankings as a guide rather than a rule book. So let's wrap up data encoding using visual cues. The encoding variables power clear and intelligent visualizations when used wisely. Avoid common mistakes, identify your data types, and pick the relevant variables. We have this summary. I think I shared this illustration. Then you'll see, you get to see it by yourselves. And then again, another variation of the chart types. No, this one I think I had given to you as a link before, how to choose the chart types. So I think before we proceed, I'd request, there's a small quiz that we have. If you can just take a few minutes to do that quiz, and then we can continue. Because I think it's important that we do it before we go to the next topic that we want to discuss. It's a simple, quick quiz on visual encoding cues that you've learned about. So I'll kindly ask either Eric or I've uploaded it on the exam platform. Let me share it with either Eric or Mary. I don't know how quick it can be done. Maybe.
What, the quiz?
Yeah, the quiz. I don't know. Are we able to do the quiz before we continue on to the next topic? Because the next one will depend on how people perform in the quiz.
Then let me go ahead and assign it. Then let you know once I've assigned it.
So do I wait or we proceed? Is how quickly can it be done?
Just about 2 minutes.
Okay. So let me share. Let me just share the link with you. Then I'll wait. So Eric will assign the quiz to everyone, and then we can just quickly do it. Then we can proceed to the next topic. It's about visual encoding, just to see that we've grasped the concept. Yeah, so just give Eric some time. He's assigning it to you. So you look at the links that I've sent, and then you just you say, I mean, you select which visual encoding queue that you can see has been used. Some of them are actually multiple, but I just want you to pick one, and then we'll discuss.
So I've assigned, so you can go ahead and do the quiz now.
So I give them about how many? 20 minutes?
Yeah, yeah.
Okay. Eric, some of them are saying they're yet to get the account, so they're not able to access the exam.
Who does not have an account yet so that I can set it up right now?
She's called Caroline Amukono.
Okay, let me just give me a second. Caroline, if you can send me a message. Caroline, WhatsApp me on that line, then I'm going to help set you up.
Eric, some people are saying that their portal is taking too long to open.
Just try and do a hard reset, Shift Control R to try and reset it in case you're facing that problem.
Yeah, I think I realized that too. If you refresh,
Yeah, just refresh the page if it's taking too long.
yeah. Is it the same as is it Control F5?
No, the Control Shift R just does a hard reset of the page.
Okay. So are we all done with the exam? So from what I can see on the dashboard, it seems the questions were quite a tall order for some of us. Maybe they needed, probably they needed more time to digest. I think we'll just go through again. So we'll start with the first one. So let's start with the first one, the one on Usain Bolt, the one, the New York Times Interactive, the one on Usain Bolt. So the encoding variables that were used for this visual were color. So natural colors were used to encode bronze, silver, and gold. So there was color, and then there was X and Y. So X, there was also X and Y. Some of the encoding variables, I didn't put them there. Yeah, I just didn't want to create a confusion. But so there was a combination of color, and then there was X and Y. X being meters behind the bolt, and then Y being the year. Olympic medals, encoding variables, we had color. Color was for continent. We had size being the number of medals. And then we had X and Y. So apart from the variable, from the options that I gave, then we have also additional variables, because remember, they can be used in combination. So so there was color, size, and then X and Y for Olympic medals. Basketball teams performance. So we had Y-axis as baseball teams. Then again we had Y-axis salaries. So there was salaries, and then there was baseball teams for Y. So we had color. So that was a trend for good or bad, and then size. So we had a combination of the Y, color, and size. So X plus Y, and then color and size. For basketball teams performance, we had X and Y. So that is X plus Y. So that was X and Y for basketball court map, color for points per region, and then size for the number of attempts. Football clubs league dominance. We have X variable being the timeline. We have Y being for teams, and then shape plus color representing event. So that was a goal, pass, and shot. So just go back to the links that I gave and try to relate the visual cues with what we've discussed. Is there any question on data encoding? The visual cues that you can use when you are encoding, when you are visualizing. So that was it for data encoding. We now move on to the role of interactivity in data visualization. I'll share the screen. Let's look at the features and role of interactivity in data visualization. So interactive visualization is a field of computer science and programming that is focused on graphic visualizations and improving the way we can access and interact with information. Graphic visualizations also refer to the graphic displays used by analytics and business intelligence tools. So you'll find that business intelligence tools in the subsequent classes, we'll call them BI. At some point, you'll interact with BI when Eric will take you through visualization with the BI tools in the coming lessons. For visualizations to be considered interactive, they must have an aspect of human input. For example, clicking on a button, moving a slider, as well as a response time quick enough to show a real relation between input and output. So this usually comes in the form of, we call them coordinated visualizations. Visualizations grant users the ability to explore, manipulate, and interact with data by employing dynamic charts, changing colors and shapes based on queries or interactions. Importantly, interactive visualizations also offer better access to real-time data, which makes them valuable in dashboards for a variety of organizations. The ability to view data as it comes in and shifts is vital for making the best and most accurate decisions. So let me just share this link of what I mean by real-time data. We might all know, but I'll just share the link for reference. An example of a real-time data is stocks, live stocks. So I've just shared it there. If you can just open, you will see, even without refreshing the page, the data changes. So that's an example of real-time data. So back to our presentation. We look at how to use interactive visualizations. Interactive visualizations are a fantastic tool in a variety of settings, thanks to the ability to optimize the way information is displayed. The most common applications for interactive data visualizations is directly in dashboards. At some point, we'll look at what you call dashboard storytelling. That is what BI tools are all about. It's all about dashboard storytelling. So in dashboards, we're using long tables of numbers and data would be impractical and time consuming. The use of these visualizations make dashboards an ideal tool for a high level understanding of an organization, department, or project. Including them in a dashboard allows organizations to compartmentalize data and create hierarchies, moving granular information to inside the visualization, or simply to a different tab. In interactive visualizations, we shall look at features. This point on moving granular information to inside the visual is usually called drill down. We'll look at it later. It's called drilling down. Additionally, interactive visualizations are excellent when implemented in BI reports, that is business intelligence, because they can make them more engaging, interesting, and easier to read. These data viz tools provide organizations with the ability to also diversify the way they display data. This allows for a deep understanding and more customizable analysis, which can produce different insights and unexpected results. Even when displaying information for clients, interactive visuals supply a more attention-grabbing report. So here I'll give the definition of BI reporting tools, that is business intelligence. BI reporting tools is a term used to describe types of platforms that are designed to collect, analyze, transform, and report data from various data sources and present them in a visual manner, often using interactive dashboards that provide actionable insights. So for nowadays, the trend for company reporting is the use of dashboard storytelling, like I said. So those are BI reporting tools. We look at the benefits of interactive visualization. When it comes to business and big data, more isn't always better. This is because raw data, when captured and stored in data silos, simply isn't valuable unless it's being broken down, evaluated, and acted upon. It's been suggested that as little as 1% of the world's data is effectively analyzed, with the rest either being captured and held indefinitely or never captured at all. And as the amount of data being created on a daily basis grows from year to year, ever more valuable information is slipping through the cracks. There was a report by, as you shall look at, there's a company called Salesforce. It's one of the most powerful BI tools. They did a report on how much time employees spent on analyzing data, and it was quite a lot of time. And so they came up with the conclusion that through the use of the BI tools, employees would spend less time analyzing data. So bad data, which is to say data that is either inaccurate or incorrectly analyzed, has been shown to cost businesses as much as 25% of their revenue in certain situations. But it doesn't have to be this way. Often, getting the most out of analyzed data is simply a matter of understanding data visualization. So there was a survey by Salesforce, the company that I was talking about, which says 52% of employees surveyed say that they spend too much time updating spreadsheets. So 52% of employees surveyed say that they spend too much time updating spreadsheets. I think this is the norm. This is common in most organizations now. So the benefits of data visualization, number one is it helps us to identify causes and trends more quickly. 93% of all human communication is visual, and it's been suggested that the human brain is capable of processing images 60,000 times faster than it does text. So as such, it seems like a fairly inefficient use of time to try to share complex data concepts using words on a page. By reviewing data analysis through the use of easily digestible imagery in whatever form that might take, and manipulating that data in order to better understand it, leaders can comprehend and act on valuable information more quickly. So the first benefit was identifying causes and trends more quickly. The second one is it helps us in seeing relationships between daily tasks and business operations. It can be difficult to fully comprehend how daily business operations affect a company's bottom line, but interactive data visualization makes it possible. By interacting with the data to put focus on specific metrics, decision makers are able to compare specific throughout definable time frames, identifying cause and effect relationships that would otherwise likely be overlooked. So point number 2 was it helps us in seeing relationships between daily tasks and business operations. Benefit number 3 is it helps us in telling a story through data. Human beings are linear creatures. We like to see how things develop and progress across time. Unfortunately, seeing data presented as a string of numbers does not generally allow for that kind of linearness. On the other hand, by allowing users to interact with data presented in a clearly visual manner, a data-intensive story becomes visible. This promotes a better understanding of data. I was talking about dashboard storytelling, and this is where it comes in. It helps us to tell a story through data. So this is achieved through interactive data visualization. Again, benefits of interactive data visualization. This is from another research firm. It's related to the first class of benefits that you talked about. This is just another angle. So number 1, it helps us to ask multiple questions. Interactivity allows us to pose multiple questions per visual, allowing us to switch axes or add confabulating factors, which could be very useful for survey data, and allowing users to break down responses to a specific question by gender, age, or perhaps occupation. So it helps us to ask multiple questions. Then you focus on detail. Interactivity allows users to zoom into a visualization, physically selecting an area of interest and blowing up that area of the chart. A good example is Google Maps. Hover information is also incredibly useful. If you are built using a choropleth, which is also called a gradient map, that visualizes the relative populations of different countries, allowing users to hover over a country to get the exact population value is much more useful than simple providing a color gradient legend. So that was a focus on detail. And then it helps us to better user experience. This is another point. Interactivity is particularly powerful when you allow users to select points or series in a chart and for a summary of the relevant data to appear. This allows us to build clean-looking visualizations that are actually very rich and provide a tool for viewers to explore your data as little or as much as they are interested. So it gives us a better user experience. Let's look at visualizing value in data. Compiling and comprehending data can be a difficult prospect, with 53% of the surveyed employees claiming that gathering data takes actual manual effort. I think let me share these 2 links for you. Links to these reports by Salesforce. Then you can look at the metrics that they use to come up with these analysis. So a minute, I'm just trying to share the links with you. There seems to be an issue with that website. All right, I'll from the notes, you'll get the links from there. Then you can click on them. Then you can have a look at them at your own time. So I think since we are breaking at 1:15, I'd like us to break, and then when we come back, we look at some of the best interactive data visualizations. Remember, we had said we have static and interactive. Now we are dealing with the interactive. So we'll have a look at some of the best examples of data interactive visualization and have a brief discussion about them. So back to Eric or Mary.
Okay, thank you for that. Yeah, so let's go ahead and take the 1 hour lunch break. Then we'll be back at 1:15 to continue with the session.